Hello, everyone. I am going to go over the remainder of the sustainable buildings content in this presentation. And so I'm going to go over Energy Star buildings, passive house, um, cooperative housing, tiny houses, straw bale, and cob. And we're going to start with Energy Star. So Energy Star, this is one of those energy efficiency ratings. The Energy Star program, now this is a little bit different than Energy Star buildings. Energy Star has been around for a long time, decades at least. This is run by the US EPA, the Environmental Protection Agency. And the goal here really is just to make it easy as possible for folks to buy energy efficient appliances. So if you see this logo, this Energy Star logo on a TV, dishwasher, whatever, heat pump, um, LED, whatever, you know that it's past a certain minimum level of efficiency. We can go over those standards later. We will go over Energy Star standards for heat pumps, but for now, just know that if you ever want to buy something, this means that it's relatively efficient. Okay, so that's been around for a while. I put a link in the presentation to the database if you're interested in searching around for Energy Star products. Energy Star Buildings um, is a way to, it's sort of like Energy Star for buildings. So it assures that a building has a certain minimum level of efficiency. I'll get to the specifics here in a minute, but to give you some context, they they have found that they're about 10% more efficient than code-built homes, and code-built is pretty robust, but about 20% efficiency, 20% more efficient on average than like on an average home. So the reason that that 20% number is higher is because we have a lot of older homes that were built to code at the time, which was um, less robust than the new codes. So on average, you're going to get about a 20% improvement on your energy efficiency, which means you're going to save about 20% of your energy cost. And they address pretty holistically. So you have a high efficiency thermal enclosure system, heating and cooling. They actually go to proper water management to protect building components. So it is like a safety and durability standard as well. And all of your appliances, everything in the house has to be Energy Star rated. So I want to put a little context to that 20% number just to give you a sense of what that means um, in real dollars in the real world. So this is information from the U.S. Energy Information Administration, and it shows the average consumption, household consumption per year in energy cost or energy amount, excuse me, in million BTU or MMBTU. Okay, and we're comparing the U.S., the Mid-Atlantic region, and then Pennsylvania. And then this is the average energy expenditure per household per year in the U.S., the Mid-Atlantic, and Pennsylvania. So you can see it's about 2350. They didn't give me a firm number, so I'm ballparking that at 2350. So at 20% savings, that results in $460 per year. So that's real money, right? I mean, it's not, you're not going to get wealthy off of this, but that's real money. And then if you take that over 10 years, most people live in their house for 7, 8, 9 years. That's almost $5,000. And I mean, if you invest that money, if you would take that savings and invest it in the market, the stock market, the average return over the last 30 years is about 10%. And so that money would actually be higher. So if you invest all this money every year that you save, that would end up, close to $7,000 after 10 years. So I just wanted to provide a little context. Sometimes we throw around these numbers like 10%, 5%, 20%, whatever. What does it really mean? I mean, that's real money if you are the average household in the U.S. And these standards are based partially on the climate that you live in. And so probably in your quiz, I'll have you explore these a little bit more in depth. But these are the official climate zones here from from the EPA website. And you can see that Philadelphia, we're actually down here in yellow, so we're climate zone 4. And if you want to, here's just a zoomed in view, and you can see Pennsylvania actually has multiple climate zones, 3 to be exact, right? So we have zone 6, which is kind of a colder climate, and then a little bit warmer climate. And then here, because we're closer to the water, to the Atlantic, we're a little bit more mild climate. Okay, so we're climate zone 4. So if you wanted to see what the Energy Star standards are for climate zone 4, you can go to the website. I provided a link here. Feel free to explore if you want. But here are the standards right after I reintroduce some key terms. So remember, ACH is air changes per hour. That means how many times the air all of the air in a building is exchanged every hour. And this is based on your ventilation rate, basically. So it's basically how much fresh air you get. ACH 50 is air change per hour when the house is depressurized at minus 50 pascals with respect to outside. So we talked about the blower door where you put that giant fan in the front door. You depressurize the house to a negative 50 pascal. And how many times is the air change in the house at that? So this is like a really standard way to measure air changes per hour and also just air leakage in general. Also peak heating and cooling load. So this is the sort of the energy, the power demand over the course of the day and the year kind of goes up and then it'll go down. Like in the summer, right? It goes up, peaks in the middle of the day when it's really hot and all the air conditioners are on and so forth. And then it kind of, goes down toward the end of the day. So the peak demand is that high point in power demand. So your peak heating and cooling load is throughout the entire year. What's your heating system? What's the most heat it can put out in BTUs per hour? Your cooling system, what are the most BTUs per hour it can remove from the building? And that's your peak heating and cooling load. That comes in to play in the Passive House standards. Okay, so let's look at Pennsylvania's um, Energy Star standards. There's a lot here. I'm not going to go over it all, and I'll have you explore this in a little more detail in your quiz. But just so you know, it tells you basically, in order to get Energy Star rating, you have to achieve all of these efficiency standards. So this is the SEER level is your cooling energy efficiency, your heating efficiency, right? So depending on the type of equipment that you have to meet certain standards. Insulation levels, here's your air ACH 50 so that your air changes per hour at 50. Okay. You have to have Energy Star windows and doors. You have to have certain efficiency. EF is energy factor. Okay, so that's an efficiency metric. You have to have a programmable thermostat, and then all of your ducts have to be in the conditioned space. And then all of your appliances and lighting have to be Energy Star. Okay, so you have to meet all of these in order to get Energy Star certification. So you can see it's very robust. We're dealing with the envelope and the heating and the cooling and the lighting and even hot water heating is included in here. And so if you meet all of those, you can get your Energy Star certification. Okay. So Passive House certification is the second one we're going to look at here. This is also energy based. Okay, so this is not a holistic metric like LEED or living building. So this is energy based. So this is, for lack of a better way to put it, it's basically a more robust Energy Star certification. So it's Energy Star Plus, if you will. So they look at your building tightness just like Energy Star does, but they also add things like your peak heating and cooling load, right? So that's down here. Your peak heating demand has to be under a certain amount per square foot. We'll get into this in a little more detail later, but the point is you need to make sure that your systems aren't oversized um, and that you don't have too high of a heating peak or a cooling peak in your building. And it's all based on square footage. You have your building tightness here as well. Now this is really interesting. This is your source energy. So with Energy Star, they just measure the energy that you use on site. With source energy, this goes back to the stuff we talked about earlier. Remember we looked at that flow chart, the Sankey diagram, and you have your electricity sector, and you go up, sort of upstream to the left on that diagram, and that's like your solar and nuclear and coal and so forth, which is also called primary energy. So Passive House actually takes into consideration where you're getting your energy from. Whereas Energy Star, you look at how much energy you use. It doesn't matter if it's solar or nuclear or coal based. But Passive House, in order to actually be more robust, looks at your source energy. So that's pretty important. And the overall, because it's so efficient, because these standards are so robust, and frankly pretty difficult to get, 60 the average energy savings are about 60 to 70%. So remember, Energy Star was about 20%, and this is 60 to 70%. So that's pretty serious stuff. Sorry I did not go over the heat recovery system. We'll go over this later. That's basically a type of ventilation system that recovers heat when you're removing, let's say it's in the winter, you're removing warm air from the building. to get fresh air in, and so it actually pulls some of the heat from that warm air going out and brings it back in with the fresh air coming in. We'll talk about that a little more later. All right, so 67%. So let's do that same sort of mental exercise that we did before. So based on our average cost in PA of 2350, we'll go on the low end of passive house savings at 60%. So that's almost $1,400 a year in savings, which is almost $14,000 over 10 years. And then if you would invest that every year at a 10% return, you're going to get close to $20,000. So passive house is a very robust standard, saves you a lot of energy, and this results in real savings. Now, they are a little more expensive, but they do tend to pay for themselves over the life of the house. Okay, so those are the two additional energy efficiency standards. And sorry, here's a chart. I forgot about this. This is a chart that shows you a general comparison of the additional robustness of your passive house standard and your passive house plus standard, right? So Energy Star's here, the newest Energy Star, and then you can see passive house is all of that plus a lot more. It's just a way to kind of visualize it. This is building code, IECC, International Energy, what is that? International Energy Code. And so this is pretty robust, but then you have Energy Star that's even more, and then passive house that's even more. Okay, so just kind of a review here. The three energy metrics that we went over were benchmarking, so that we went over that before. That was EUI, which is energy use per square foot per year. And that's just kind of a general indicator of energy efficiency. It considers climate, it considers the type of building. Remember we talked about it's important to consider whether it's a hospital or a hotel or a restaurant or a commercial building or a church or whatever. So it's important to compare buildings of similar types in similar climate zones. One of the nice things about benchmarking, it's really easy to do. You just take a year's worth of utility bills and you divide by the square footage and then you compare it. Energy Star, remember, requires specific levels of insulation, specific building tightness, specific efficiency of heating and cooling equipment, and so forth. So it's an energy efficiency standard that's meant to address just about everything in a house. And that should save you around 20% of your energy. A passive house is like a more robust Energy Star, and that should save you on the order of 60 to 70%. So it includes everything the Energy Star does and a lot more, but also Energy Star requires a certain level of building tightness, and passive house requires a building to be even more tight. And so it's sort of Energy Star to the nth degree. Okay, so that's a wrap up of the energy efficiency metrics for sustainable buildings. In the next presentation, I'll go over the remaining sustainable building types.